Hello everyone, I'm Tarun from Data Science Department. I'm here to give the information of survey of learning classifier systems and games from the embedded systems. A survey of learning classifier systems in games. LCS in games. LCS means learning classifier systems in games. Introduction to learning classifier system. Generally, let us know what is LCS, that is learning classifier system. LCS are adaptive rule based that combine machine learning with evolutionary algorithms. They are designed to learn and adapt to complex environments through interaction and feedback. LCS have been increasingly applied in game environments to develop intelligent and adaptive agents. Overview of the survey. The survey reviews recent research on LCS applications in various game genres. It explores the different LCS architectures, algorithms, and their performance in game scenarios. The goal is to identify trends, challenges, and future directions in this research area. This is the flowchart of the survey of the LCS in the games. Just go through this. Background on classifier systems. Classifier systems originated from the work of the John Holland in the 1970s. They consist of a set of condition action rules called classifiers. These systems evolve classifiers based on their success in the environment. Structure of learning classifier systems. LCS typically include a population of classifiers, a learning component, and a genetic algorithm. Classifiers are evaluated based on their accuracy and strength. The system updates classifiers through reinforcement learning and genetic operations. This is the general flow diagram, architectural diagram of the LCS, which includes environment and in the learning classifier systems, with include of detectors, effectors, message space, AOC, clearinghouse, rule-based GA. Variants in various of LCS literature. Several variants exist including XCS, that is Extended Classifier System, UCS, Unordered Classifier System, and others. XCS is one of the most popular due to its accuracy-based fitness mechanism. Different variants are tailored for specific types of environments or tasks. Here is the diagram which shows the variants from the bagging datasets to BS1, BS2, BS3. These are random bootstrapped samples, and then it converted to classifier 1, 2, 3, and from that built multiple learners in parallel to combine, and then the final output is prediction. Applications of LCS in game environments. LCS are used for developing adaptive game agents that can learn strategies over time. They are effective in environments with uncertainty and dynamic changes. These systems enable agents to evolve complex behaviors with minimal prior knowledge. Game-based and gamified design, which includes some any meaningful goal for social interaction, engaging stories for long-term motivation, fantasy environment for inquiry and discovery. LCS for game playing. LCS have been applied to classical games like Pac-Man, Tetris, and Snake. They learn optimal moves through interaction with the game environment. Results show the LCS can discover competitive strategies and improve over time. LCS in real-time strategic games. In RTS, LCS helps manage resource allocation and strategic decision making. They adapt to opponents' tactics through continuous learning. Studies demonstrate that LCS can outperform traditional rule-based approaches in RTS environments. LCS for procedural content generation. LCS are utilized to generate game content such as levels, maps, and items. They evolve content that adapts to player preferences and skill levels. It is based on skill level to adapt the people for the overall game. This approach enhances replayability and personalized gaming experience. Performance metrics in LCS research. Common metrics include accuracy, fitness, converse speed, and gameplay success rate. Performance evaluation is crucial for comparing different LCS variants. Researchers also consider computational efficiency and scalability. Researchers also consider computational efficiency and scalability, which includes JSON, math, contextual relevance, and output calibration. Advantages of using LCS, that is, learning classifier systems in games. LCS provides adaptive and flexible solutions that improve with experience. They can handle noisy and uncertainty environments effectively. LCS facilitate the emergence of complex behaviors from simple rules. These are the five key benefits of game-based learning from the LCS. On its instructional scaffold, customized e-content motivates students to focus on learning from learning games, distributed learning process, better knowledge retention. Challenges in applying LCS to games. Designing appropriate fitness functions remains a challenge. Computational complexity can be high, especially in large state spaces. Balancing exploration and exploitation is critical for effective learning. It is a player type includes the challenges, feature games, learning strategies, game adaptation engine, user gameplay input, interactions, analyzation of input, and user feedback on gaming elements, assessment of feedback, and adaptation of users' profile. Recent advances in LCS for games. Hybrid approaches combining LCS with neural networks have been proposed. Multi-objective optimization enables balanced gameplay strategies. Online learning techniques improve real-time adaptation in dynamic environments. Game analytics, game player analytics, game development analytics, game publishing analytics, distribution channel analytics. Case study LCS in a maze navigation game. An LCS was used to evolve navigation strategies in a maze environment. The system successfully learned to avoid obstacles and reach goals efficiently. Results indicates faster convergence compared to traditional reinforcement learning. Future directions in LCS research, interaction with the deep learning for complex features, extraction is promising. Developing scalable LCS for large multi-agent game environments is ongoing. Exploring transfer learning could allow agents to adapt to knowledge across different games. Future research directions includes interdisciplinary approaches, longitudinal studies, assessment tools, ethical considerations. Open challenges and limitations. Ensuring robustness and generalization remains difficult. Real-time learning in highly dynamic games requires further optimization. The interpretability of evolved rules can be limited in complex systems. Practical implications for game developers and LCS can create more engaging and adaptive non-player characters (NPCs). They enable personalized game experiences based on player behavior. Incorporating LCS in game design can lead to innovative gameplay mechanisms. Game design process. Summary of key findings. LCS are effective in developing adaptive and intelligent game agents. Various architectures have been successfully applied across multiple game genres. Despite challenges ongoing, research is expanding their capabilities and applications. Coming to the conclusion of the learning classifier systems of games, LCS, that is, learning classifier systems, offer a promising approach for adaptive game AI development. Continued research with enhanced their efficiency, scalability, and integration with other AI techniques. The future of LCS and games holds potential for creating more dynamic and personalized gaming experiences. That's it. Thank you. I hope the presentation will give you some of the information about the learning classifier systems on games. Yeah, thank you very much.